deep learning. Okay. Now, what is deep learning? Deep learning is a set of machine learning. Why we use deep learning? Deep learning is used to mimic the human expressions. Okay, human intelligence, how human behave, these things. Now, at first we have artificial intelligence, then machine learning. That means machine learning is a subset of artificial intelligence and deep learning is a subset of machine learning. What are the use of deep learning? Deep learning is used in various fields, like in medical field. How deep learning is used in medical field? To detect cancers, we can use deep learning. Okay. How it process? It takes, if a patient want to know that is there any chance to affect with cancer, or he or she may suffer in cancer, that thing can be detected in early stage using the deep learning. When deep learning was not there, not in the scenario, then a person go to doctor and diagnoses all that things, and then he or she could know that. But using deep learning, we can make a machine in such a way that it can analyze the images by itself and detect if there is any cancer cell or not. Now another thing is uh, automa- automatic car driving. Okay. In this case, what the car performs, car can automatically detect the object means any cars are present there or any obstacles are there, means how the car is running from middle of the road or at the end. Okay, at the side. This can be monitored by the deep learning, and using that technique we can also recognize images. Some, if there have some pictures image, then we can identify which one is the image of sunflower, which one is the image of rose, such things. Okay. And another thing is robo navigation. Now, in this present situation, every big manufacturer company tries to reduce the human resource, tries to reduce the human resource, and they are increasing the use of robots in this type of industries. Okay, now these robots are machines, and that have that much intelligence to count all the packages and where it have to place. Okay, how much means this robot can perform the task of an human. Okay, then another thing of deep learning is language translation. Okay, language translations means, suppose you have visit
Kamalika ma'am, your
some.
screen is not visible.
No, I am not sharing anything.
अच्छा, 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 अच्छा. Then okay.
Till now I am not sharing. Okay.
Yes, please continue.
Okay. So there is some headings are written in the uh, regional language, but as an outsider you cannot understand that language. How you can understand that? How, if there is no deep learning mechanism is there, then you have to ask any local person to translate the thing. Okay, but if you are using language translation application, then you can translate that language easily. Okay, these are the applications of deep learning. And one more application which is going to explore, that is music composition. This thing is going to explode. This is not so much explode, but using the deep learning we can also make the composition. Okay, deep learning is based on human brain. Okay, human brain means neurons. Okay, means we collect some input, process the data, and produce some output. Same mechanism is used in deep learning. It also takes some input, then produces or performs some processes, then produce the output. Okay, now
Familiar with image recognition.
now the
How does image
screen and
recognition
audio
work?
is
You can
visible and
train this
audible.
application or your machine to recognize
Yes, ma'am.
whether given
Okay.
image is a cat or a dog. And this is how it works at a very high level. It uses artificial neural network. It is trained with some known images, and during the training it is told if it is recognizing correctly or not. And then when new images are submitted, it recognizes correctly based on the accuracy, of course. So a little quick understanding about artificial neural networks. So this is the way it does is you provide a lot of training data, also known as labeled data. For example, in this case, these are the images of dogs, and the network extracts some features that makes a dog, right? So that is known as feature extraction. And based on that, when you submit a new image of dog, the basic features remain pretty much the same. It may be a completely different image, but the features of a dog still remain pretty much the same in various different images, let's say compared to a cat. And that's the way artificial neural network works. We'll go into details of this very shortly. And once the training is done with training data, we then test it with some test data which is basically completely new data which the system has not seen before, unlike the training data. And then we find out whether it is predicting correctly or not. Thereby we know whether the training is complete or it needs more training. So that's how at a very high level artificial neural network works. So this is what we are going to talk about today. Our agenda looks something like this. What is deep learning? Why do we need deep learning? And then what are the applications of deep learning? One of the main components, the secret sauce in deep learning, is neural networks. So we're going to talk about what is neural network and how it works, and some of its components, like for example the activation function, the gradient descent, and so on and so forth. So that as a part of working of a neural network, we will go into a little bit more details how this whole thing works. So without much further ado, let's get started. So deep learning is considered to be a part of machine learning. So this diagram very nicely depicts what deep learning is. At a very high level, you have the all-encompassing artificial intelligence, which is more a concept rather than a technology or a technical concept, right? So it is more of a concept at a very high level, artificial intelligence. Under the hood is actually machine learning and deep learning. And machine learning is a broader concept, you can say, or a broader technology, and deep learning is a subset of machine learning. The primary difference between machine learning and deep learning is that deep learning uses neural networks and it is suitable for handling large amounts of unstructured data. And the last but not least, one of the major differences between machine learning and deep learning is that in machine learning, the feature extraction or the feature engineering is done by the data scientists manually. But in deep learning, since we use neural networks, the feature engineering happens automatically. So that's a little bit of a quick difference between machine learning and deep learning. And this diagram very nicely depicts the relation between artificial intelligence, machine learning, and deep learning. Now, why do we need deep learning? Machine learning was there for quite some time, and it can do a lot of stuff that probably what deep learning can do, but it's not very good at handling large amounts of unstructured data, like images, voice, or even text for that matter. So traditional machine learning is not that very good at doing this. Traditional machine learning can handle large amounts of structured data, but when it comes to unstructured data, it's a big challenge. So that is one of the key differentiators for deep learning. So that is number one. And increasingly for artificial intelligence, we need image recognition and we need to process, analyze images and voice. That's the reason deep learning is required compared to, let's say, traditional machine learning. It can also perform complex algorithms, more complex than, let's say, what machine learning can do, and it can achieve best performance with the large amounts of data. So the more you have the data, let's say reference data or labeled data, the better the system will do, because the training process will be that much better. And last but not least, with deep learning, you can really avoid the manual process of feature extraction. Those are some of the reasons why we need deep learning. Some of the applications of deep learning. Deep learning has made major inroads, and it is a major area in which deep learning is applied is healthcare. And within healthcare, particularly oncology, which is basically cancer related stuff. One of the issues with cancer is that a lot of cancers today are curable. They can be cured. They are detected early on. And the challenge with that is when a diagnostic system is performed, let's say an image has been taken of a patient, to detect whether there is cancer or not, you need a specialist to look at the image and determine whether the patient is fine or there is any onset of cancer. And the number of specialists are limited. So if we use deep learning, if we use automation here, or if we use artificial intelligence here, then the system can, with a certain amount of the good amount of accuracy, determine whether a particular patient is having cancer or not. So the prediction or the detection process of a disease like cancer can be expedited. The detection process can be expedited, can be faster without really waiting for a specialist. We can obviously then, once the artificial intelligence detects or predicts that there is an onset of a cancer, this can be cross-checked by a doctor. But at least the initial screening process can be automated, and that is where the current focus is with respect to deep learning in healthcare. What else? Robotics is another area. Deep learning is majorly used in robotics, and you must have seen nowadays robots are everywhere. Humanoids, the industrial robots which are used for manufacturing process. You must have heard about Sophia, who got citizenship with Saudi Arabia, and so on. There are multiple such robots which are knowledge oriented, but there are also industrial robots that are used in industries, in the manufacturing process, and increasingly in security and also in defense. For example, image processing. Video is fed to them and they need to be able to detect objects, obstacles, and so on and so forth. So that's where deep learning is used. They need to be able to hear and make sense of the sounds that they are hearing. That needs deep learning as well. So robotics is a major area where deep learning is applied. Then we have self-driving cars or autonomous cars. You must have heard of Google's autonomous car, which has been tested for millions of miles and pretty much incident-free. There were, of course, a couple of incidents here and there, but it is considered to be fairly safe. And there are today a lot of automotive companies. In fact, pretty much every automotive company worth its name is investing in self-driving cars or autonomous cars. And it is predicted that in the next probably 10 to 15 years, these will be in production and they will be used extensively in real life. Right now, they are all in R&D and in test phases, but pretty soon these will be on the road. So this is another area where deep learning is used. And how is it used? Where is it used? Within autonomous driving, the car actually is fed with video of surroundings, and it is supposed to process that information, process that video, and determine if there are any obstacles. It has to determine if there are any cars in the side. It will detect whether it is driving in the lane. Also, it has to determine whether the signal is green or red, so that accordingly it can move forward or wait. So for all these video analysis, deep learning is used. In addition to that, the overall training to drive the car happens in a deep learning environment. So again, a lot of scope here to use deep learning. A couple of other applications are machine translation. So today we have a lot of information, and very often this information is in one particular language, and more specifically in English. And people need information in various parts of the world. It is pretty difficult for human beings to translate each and every piece of information or every document into all possible languages. There are probably at least hundreds of languages, or if not more. To translate each and every document into every language is pretty difficult. Therefore, we can use deep learning to do pretty much like a real-time translation mechanism. So we don't have to translate everything and keep it ready, but we train applications or artificial intelligence systems that will do the translation on the fly. For example, you go to somewhere like China and you want to know what is written on a signboard. Now, it is impossible for somebody to translate that and put it on the web or something like that. So you have an application which is trained to translate stuff on the fly. So you probably, this can be running on your mobile phone.
Good grammar and spelling
You
are
scan this,
important.
the application will instantly translate that from Chinese to English. That is one. Then there could be web applications where there may be a research document which is all in maybe Chinese or Japanese, and you want to translate that to study that document, or in that case you need to translate that. So therefore deep learning is used in such situations as well, and that is again on demand. So it is not like you have to translate all these documents from other languages into English in one shot and keep it somewhere. That is again pretty much an impossible task, but on a need basis. So you have systems that are trained to translate on the fly. So machine translation is another major area where deep learning is used. Then there are a few other upcoming areas where synthesizing is done by neural nets. For example, music composition and generation of music. So you can train a neural net to produce music, even to compose music. So this is a fun thing. This is still upcoming. It needs a lot of effort to train such neural net. It has been proved that it is possible. So this is a relatively new area. And on the same lines, colorization of images. So these two images on the left hand side is a grayscale image or a black and white image. This was colored by a neural net or a deep learning application. As you can see, it's done a very good job of applying the colors, and obviously this was trained to do this colorization. But yes, this is one more application of deep learning. Now, one of the major secret sauce of deep learning is neural network. Deep learning works on neural network or consists of neural network. So let us see, what is neural network. Neural network or artificial neural network is designed or based on the human brain. Now, human brain consists of billions of small cells that are known as neurons. Artificial neural networks is, in a way, trying to simulate the human brain. So, this is a quick diagram of biological neuron. A biological neuron consists of the major part, which is the cell nucleus, and then it has some tentacles kind of stuff on the top called dendrite, and then there is like a long tail which is known as the axon. Further again, at the end of this axon are what are known as synapses. These in turn are connected to the dendrites of the next neuron, and all these neurons are interconnected with each other. Therefore they are like billions of them sitting in our brain, and they're all active, they're working. They, based on the signals, they receive signals as inputs from other neurons or maybe from other parts of the body, and based on certain criteria they send signals to the neurons at the other end. So they get either activated or they don't get activated based on, so it is like a binary gates. So they get activated or not activated based on the inputs that they receive and so on. So we will see a little bit of those details as we move forward in our artificial neuron. But this is a biological neuron. This is the structure of a biological neuron. And artificial neural network is based on the human brain. The smallest component of artificial neural network is an artificial neuron, as shown here. Sometimes is also referred to as a perceptron. Now, this is a very high level diagram. The artificial neuron has a small central unit which will receive the input. If it is doing, let's say, image processing, the inputs could be pixel values of the image, which is represented here as x1, x2, and so on. Each of the inputs are multiplied by what is known as weights, which are represented as w1, w2, and so on. There is, in the central unit, basically, there is a summation of these weighted inputs, which is like x1 into w1 plus x2 into w2 and so on. The products are then added, and then there is a bias that is added to that. In the next slide we will see that passes through an activation function, and the output comes as a y, which is the output, and based on certain criteria the cell gets either activated or not activated. So this output would be like a 0 or a 1 binary format. Okay, so we will see that in a little bit more detail, but let's do a quick comparison between biological and artificial neuron. Just like a biological neuron, there are dendrites, and then there is a cell nucleus and synapse and an axon. We have in the artificial neuron as well these inputs come like the dendrite, if you will, act like the dendrites. There is a central unit which performs the summation of these weighted inputs, which is basically W1, X1, W2, X2, and so on. And then a bias is added here, and then that passes through what is known as an activation function. Okay, so these are known as the weights W1, W2, and then there is a bias which will come out here, and that is added. The bias is, by the way, common for a particular neuron, so there won't be like B1, B2, B3, and so on. Only weights will be one per input. The bias is common for the entire neuron. It is also common for, or the value of the bias remains the same for all the neurons in a particular layer. We will also see this as we move forward and we see deep neural network where there are multiple neurons. So that's the output. Now the whole exercise of training a neuron is about changing these weights and biases. As I mentioned, this artificial neural network will consist of several such neurons, and as a part of the training process, these weights keep changing. Initially they are assigned some random values. Through the training process, the weights, the whole process of training is to come up with the optimum values of W1, W2, and Wn, and then the B for, or the bias for this particular neuron, such that it gives an accurate output as required. So let's see what exactly that means. So the training process, this is how it happens. It takes the inputs. Each input is multiplied by a weight, and these weights during training keep changing. So initially they are assigned some random values, and based on the output, whether it is correct or wrong, there is a feedback coming back, and that will basically change these weights until it starts giving the right output. That is represented in here as sigma I going from 1 to n. If there are n inputs, wi into xi. So this is the product of w1, x1, w2, x2, and so on, right? And there is a bias that gets added here, and that entire thing goes to what is known as an activation function. So essentially this is sigma of wixi plus a value of bias, which is a b. So that entire thing goes as an input to an activation function. Now this activation function takes this as an input, gives the output as a binary output. It could be a 0 or a 1. There are, of course, to start with, let's assume it's a binary output. Later we will see that there are different types of activation functions, so it need not always be binary output. But to start with, let's keep simple. So it decides whether the neuron should be fired or not. So that is the output, like a binary output, 0 or 1. All right. So again, let me summarize this. So it takes the inputs. So if you're processing an image, for example, the inputs are the pixel values of the image, x1, x2 up to xn. There could be hundreds of these. So all of those are fed as, so these are some values, and these pixel values again can be from 0 to 256. Each of those pixel values are then multiplied with what is known as a weight. This is a numeric value, can be any value. So this is a number, W1. Similarly, W2 is a number. So initially some random values will be assigned, and each of these weights are multiplied with the input value and their sum. This is known as the weighted sum. So that is performed in this kind of the central unit, and then a bias is added. Remember, the bias is common for each neuron. So this is not, the bias value is not one bias value for per input. So just keep that in mind. The bias value, there is one bias per neuron. So it is like this summation plus bias is the output from this section. This is not the complete output of the neuron, but this is the bias for output for step 1. That goes as an input to what is known as an activation function, and that activation function results in an output, usually a binary output like a 0 or a 1, which is known as the firing of the neuron. Okay, good. So we talked about activation function. So what is an activation function? An activation function basically takes the weighted sum, which is, we saw, W1, X1, W2, X2, the sum of all that, plus the bias. So it takes that as an input and it generates a certain output. Now, there are different types of activation functions, and the output is different for different types of activation functions. Moreover, why is an activation function required? It is basically required to bring in non-linearity. That's the main reason why an activation function is required. So, what are the different types of activation functions? There are several types of activation functions, but these are the most common ones. These are the ones that are currently in use. Sigmoid function was one of the early activation functions. But today, ReLU has kind of taken over. So ReLU is by far the most popular activation function that is used today. But still, sigmoid function is still used in many situations. These different types of activation functions are used in different situations based on the kind of problem we are trying to solve. So what exactly is the difference between these two? Sigmoid gives the values of the output will be between 0 and 1. Threshold function is the value will be 0 up to a certain value, and beyond that, this is also known as a step function, and beyond that it will be 1. In case of sigmoid, there is a gradual increase, but in case of threshold, it's like also known as a step function. There is a rapid or instantaneous change from 0 to 1. Whereas in sigmoid, we will see in the next slide, there is a gradual increase, but the value in this case is between 0 and 1 as well. Now, ReLU function, on the other hand, it is equal to basically if the input is 0 or less than 0, then the output is 0. Whereas if the input is greater than 0, then the output is equal to the input. I know it's a little confusing, but in the next slides where we show the ReLU function, it will become clear. Similarly, hyperbolic tangent. This is similar to sigmoid in terms of the shape of the function. However, while sigmoid goes from 0 to 1, hyperbolic tangent goes from -1 to 1. And here again, the increase or the change from -1 to 1 is gradual and not like threshold or step function where it happens instantaneously. So let's take a little detailed look at some of these functions. So let's start with the sigmoid function. So this is the equation of a sigmoid function, which is 1 by 1 plus e to the power of minus x. So x is the value, that is the input. It goes from 0 to -1. So this is sigmoid function. The equation is phi x is equal to 1 by 1 plus e to the power of minus x. And as you can see here, this is the input on the x-axis. As x is the value is coming from, in fact, it can also go negative. This is negative actually. So this is the 0. So this is the negative value of x. So as x is coming from negative value towards 0, the value of the output slowly, as it is approaching 0, it slowly and very gently increases. And actually at the point, let me just use a pen, at the point here, it is 0.5. It is actually 0.5. Okay. And slowly, gradually it increases to 1 as the value of x increases. But then as the value of x increases, it tapers off. It doesn't go beyond 1. So that is the speciality of sigmoid function. So the output value will remain between 0 and 1. It will never go below 0 or above 1. Okay, so that is sigmoid function. Now this is threshold function, or this is also referred to as a step function. And here we can also set the threshold. In this case, that's why it's called the threshold function. Normally it is 0, but you can also set a different value for the threshold. Now the difference between this and the sigmoid is that here the change is rapid or instantaneous. As the x value comes from negative up to 0, it remains 0. And at 0, it pretty much immediately increases to 1. Okay, so this is a mathematical representation of threshold function. Phi x is equal to 1 if x is greater than or equal to 0, and 0 if x is less than 0. So for all negative values, it is 0, since we have set the threshold to be 0. So as soon as it reaches 0, it becomes 1. You see the difference between this and the previous one, which is basically the sigmoid, where the increase from 0 to 1 is gradual, and here it is instantaneous. And that's why this is also known as a step function, threshold function or step function. This is a ReLU. ReLU is one of the most popular activation functions today. This is the definition of ReLU. Phi x is equal to max of x comma 0. What it says is if the value of x is less than 0, then phi x is 0. The moment it increases, goes beyond 0, the value of phi x is equal to x. So it doesn't stop at 1. Actually, it goes all the way. So as the value of x increases, the value of y will also increase infinitely. So there is no limit here, unlike your sigmoid or threshold or the next one, which is basically hyperbolic tangent. Okay, so in case of ReLU, remember there is no upper limit. The output is equal to either 0 in case the value of x is negative, or it is equal to the value of x. So for example, here if the value of x is 10, then the value of y is also 10. Right? Okay, so that is ReLU, and there are several advantages of ReLU, and it is much more efficient and provides much more accuracy compared to other activation functions like Sigmoid and so on. So that's the reason it is very popular. All right, so this is hyperbolic tangent activation function. The function looks similar to sigmoid function. The curve, if you see the shape, it looks similar to sigmoid function. But the difference between hyperbolic tangent and sigmoid function is that in case of sigmoid, the output goes from 0 to 1. Whereas in case of hyperbolic tangent, it goes from -1 to 1. So that is the difference between hyperbolic tangent and sigmoid function. Otherwise, the shape looks very similar. There is a gradual increase, unlike the step function where there was an instant increase or instant change. Here again, very similar to sigmoid function, the value changes gradually from -1 to 1. So this is the equation of hyperbolic tangent activation function. Yeah, so then let's move on.
Okay, I am giving you a link for a quiz. Okay, you have to submit it by 15 minutes. Okay.
Kamalika ma'am, have you sent the link?
No, no, not now. I'm sharing the link. Okay.